Hello friends, in this video I want to explore with you the general approach that we're going to take when we're doing our grading. And this has to do more with mindset, but also just structuring projects rather than with any specific technique that we are going to cover later in the course. So this is more about the way we can think about grading and the way we can organize a project in our heads as we are doing it. Now, there are many ways by which we can approach grading. This is just one way, and it's the way that I personally use and have developed for myself because it personally suits my own working process. So maybe you can take whatever you want from these ideas, but feel free to explore and develop your own ideas or take bits and pieces from other people as well. Because again, there are many ways by which this type of work can be done. So there is no one way or one right way by which you can go about it. Here on this board, I have laid a few examples of some grading projects so that we can break them down and I can show you how I've approached doing those and just run you through my thought process and how I structured the project and then how I went about doing it inside of CAD. Now, the specific type of grading project doesn't really matter that much. It can be a dam, it can be a terrace, or a road, or a channel, but they all share the same principles, except that dams are obviously more complex than channels, and roads are also more complex than terraces. But the way you would build all of those is kind of the same in terms of the thinking process. So the very first thing, and I'm gonna write here on the side of the board, and I'm also gonna draw on top of these examples. But the very first thing, if there is one, is that we are going to build all of these projects in a modular fashion. So I think this is probably at least in my experience, the best way to approach grading projects, because if you're building them in a modular way, it's very natural. It's the way you would build anything in the real world. Like you won't build a house normally from a single block of material. You would lay the foundation and so on. You build everything in stages, and a house would be basically an assembly of thousands of components. And doing things in a modular way gives you more flexibility. You can, if something goes wrong, you can normally repair or do maintenance on just a single part of that whole structure instead of having to repair absolutely everything. And it's the same way in grading. So if, for example, something goes wrong during the grading process with the embankment of a dam, then you don't have to change the entire design. You can just go and repair or correct any errors in the dam or the embankment model rather. So for instance, on this dam, if I were to draw here, just let me choose a color. This dam is built in pieces, so it wasn't built in one single go or is a single element. It was built in several elements, and then those elements were combined together. So the embankment, which is this element right here, was actually one element. Then we have also the borrow pit. So this is this area right here. This is another element. And then we also have the spillway, which is this element right here. So these are all separate elements. And again, another reason why we build them in a modular fashion is so that we can measure them separately from each other, which is something that will become very important when we get to the latest stages of a design, because we want to be able to volumetrically compare these elements to each other and to the existing surface so that we can balance them out. For instance, we would normally want to balance out the volume of earth that is found in the embankment with the volume of earth that we can get out of the excavation pit or the borrow pit. But if you build them all together as a single element, it's kind of more difficult to compare them against each other and to balance them out. So if we found out that, for instance, the borrow pit does not have enough material in its current form to actually supply that material for the building of the embankment, then if we had built it in a modular fashion, then we can just go back and change the borrow pit itself. We do not necessarily have to change also the embankment. But if they were a single element, then we would have to inevitably change both of them. So it just creates more work. And so I think building things in modularity ripples out through many implications when you're doing grading, and it is my preferred way of doing things. Of course, there is also a way by which you can do, or let's say create a dam or grade a dam in a single go, and I have experimented with those, but it's personally just not for me. It doesn't provide the flexibility I need, and because clients may need changes, they may request changes. So when you start thinking about it in terms of the details of dealing with people and working on actual project, it's no longer it doesn't sound so good as it did before, because it is in fact provide more speed. So you can create a project faster if you do everything in one go, but when it comes to working with people and having to come back and do revisions, then it's not so great anymore. The second point that I would add here, and this is not necessarily in a kind of a hierarchical order, but it's just important points, and that is optimization. Now, this is very important, and especially if you're working on large projects, and it mostly has to do with optimizing the data that you're working with, especially survey data. So if you receive a contour map or a digital terrain model or survey points or whatever kind of survey data it is, you ultimately should convert it to contours, and you should always optimize those contours. I'm pretty sure that 90+% of the time the data is not going to be optimized for grading as you receive it. You have to optimize it yourself most of the time, and this is so because grading software does not do very well when the data is very heavy. And by heavy, I mean contours that have a lot of vertices on them and that contain a lot of noise. Because the way grading software works is that it has to compute all of that information that is contained in the survey data in order to perform grading operations. And if the survey data contains a lot of noise, which basically is just information, a lot of vertices that contain coordinate information, and likewise also if the contours have many vertices on them or many points, then that's also a lot of information. And the grading software has to compute all of that during its grading operations. And so if the data is very heavy in that way, it just slows everything down, and it greatly increases the likelihood that the software will crash or that you will experience certain errors or even artifacts in the grading models that you create. So it makes everything worse because then you have to spend more time correcting those errors or restarting the software if it crashes. So you can avoid all of this, or at least most of it, if you just spend less than 5 minutes or so optimizing your contours before you bring them into Civil 3D to create what's called surfaces from them, which are just basically 3D volumetric models. So we are going to cover optimization of survey data in one of the next videos, and I'll walk you through the entire process of how you do that. It's really simple, and we are also going to cover in a lot of depth in a lot of videos how we can create surfaces from those contours, because I think just repeating that process hundreds of times over and over, it's the way you would learn this in the back of your mind, basically, so you won't have to think about it. As a step 3, I'm going to call this dynamic models. And what it basically means is that we're going to build our models in a way that they can be dynamically changed if we need to make small revisions or revisions that are not absolutely fundamental in a way that they will change the entire model. So let's say if we want to reduce the level of this embankment, then we don't have to redo the entire modeling. We can just come in and with a couple of buttons, we can do that kind of a change. So we want to build those models with that in mind, that we can make quick revisions, or also explore different scenarios, which is something that clients often request, like what will happen if we increase this embankment by, let's say, 0.25 meters. How much more volume are we going to be able to store of water, and how much more is it going to cost, and so on. So you should be able to do these changes very quickly without spending a lot of effort. And in general, I would say grading a dam like this, like what you see currently on this image, shouldn't take more than, I would say, 15 minutes in the initial preliminary stages, where you're just trying to find a good position for that dam where the volumes are optimal. So where the embankment doesn't cost so much for the volume of water that you can store, for instance, and where the volume of earth that you can get from the excavation pit is enough to actually build that embankment. So these I would call preliminary stages. And once you find that position, then you can go into more detailed work, because it makes no sense to actually spend more time until you have found that site. And then the detail stages, I would say maybe another hour or so. So my point is that grading is not a very time-consuming activity, strictly speaking. It becomes time-consuming when you have to do studies or comparative studies. So you may oftentimes have to compare dozens or even hundreds of different sites before you find one which is the most optimal one. That's maybe a little bit of an overstatement. You don't have to oftentimes do this, but there are certainly projects where you may have to do that. On average, I would say every project will require some comparative studies to be done, but oftentimes, and as you get more experienced, you can kind of develop a sense of where there might be a good site, so that you can reduce the number of studies you have to do. In any case, it's always a good idea to develop your models in a dynamic way from the beginning, so that you can make changes quickly in order to, again, reduce the amount of time you have to work to perform those kind of studies. And as a point number 4, and this is probably going to be the last point, I would say this is external application. So we are going to use some external applications to complete our projects. And these are simple things like just using a spreadsheet software like either Excel or Google Sheets, as well as something like Photoshop or other kind of 2D graphic software, because I personally dislike doing the drafting kind of work in the Civil 3D software, because personally I find it to be a bit clumsy for that kind of work. And by drafting, I mean just creating those annotations, just styling the drawing a little bit to make it more clear to read. But we also may have to use external applications to do some of the analysis, for example, on channels, so channel hydraulics, or whenever we want to calculate flood and storm information, we may have to use an external application. Now, we were probably not going to do any kind of flood or storm calculations in this course, because that has more to do with design, the design aspect of creating these kinds of models. Whereas in this course, we're only strictly concerned with grading. And these are two completely separate things, even though there is some overlap or they kind of complement each other. They're very different disciplines or activities. But we may have to use some external applications, as I mentioned. At the very least, what I'm going to use in this course is Adobe Photoshop to do the drafting in. And we may also use a channel hydraulics software if we happen to require that during the channel grading sections of the course. And of course, I'm also going to use some kind of a spreadsheet software, most likely Google Sheets. For any of our GIS work, we will primarily be also using QGIS. So we will do a lot of work there. And of course, Google Earth, which is ultimately the software to which we want to be able to export all of our work. So all of these drawings should ultimately be able to go into Google Earth, as this is just a company policy for us that we use Google Earth as a communication tool with clients. So whatever work we do, we ultimately want it to be visible in Google Earth. and then we can provide that file to clients to review, and they can also then send us files back with their feedback. But what I'm trying to say with point number 4 is that there's no software that can do everything. Civil 3D is not going to be able to do everything that you may require, as sophisticated as a software that it is, but it's not good at everything. And so if you develop a mindset whereby you kind of think in terms of combining softwares together so that you can leverage each of their strengths, I think in the long term you're going to be successful. Whereas if you try to find this one software that can do absolutely everything, and I honestly have seen that so many times, people just getting frustrated that there is no software like that. I'm like, yeah, there isn't. And if you get hung up on that, then you're just going to have a hard time in this industry in general, because again, there's just isn't a software like that. So you do have to combine different applications. Now, we can start a new list to discuss how grading actually works in terms of application. So currently in these drawings, we only see a 2D representation of these dams. But what you should understand is that these 2D drawings are actually just a byproduct of a 3D model. And this is what grading ultimately is just 3D modeling. So if you've used any kind of a 3D modeling application in the past, like SketchUp or Blender or 3ds Max or any of those, then grading is very similar. It's just that it's done with a more precise, in a more precise manner, and it's particularly targeting certain volumetric values. Whereas in typical 3D modeling, you don't have to necessarily do that. So grading is just more oriented towards these civil engineering kind of works and details. But essentially, it's just 3D modeling. It's really no different than that. We have the basic just extrusions of shapes and beveling, and as well as cutting through 3D shapes and so on. So if you just think of it in that way, then it becomes a little bit more simple and kind of develops a flexibility in your thinking that, well, if it's just like 3D modeling, then you can also manipulate those objects in the same way that you could in a traditional 3D modeling application. But in any case, what you require to have or to develop to learn grading is just to be able to think in 3 dimensions, because what you would normally receive is, let's me draw here. So you would normally receive some kind of a contour map, and then a basic concept plan. So somebody will maybe send you kind of an outline of a water body, of where perhaps they want to have some kind of a pond or a dam. And that's just about it. Like, you're going to maybe receive that in Google Earth or on a sketch, on a paper, or whatever it is. But you're going to receive a 2D representation of what a client actually wants in 3 dimensions, because that's what reality is made up of. So your job is to actually add that third dimension to what is just a 2D representation. And that third dimension is the volumetrics. So once you come into Civil 3D, you have to be able to think, okay, how can we create this to the exact dimensions and volumes that the client required? So you immediately have to start thinking how you can translate something that is on 2 dimensions into a third dimension, which is the volume. So if there is a challenge in grading, it's not actually in the technicalities, because those are very rigid. They're very clear, like the grading criteria, the dimensions, those things are very clear. And even the software is not daunting, because, to be honest, you don't have to know more than 5% of almost any software out there, including Civil 3D, to be able to work professionally with it in a field. But the challenge is to actually visualize things. And that is something that nobody can teach you. A software can be taught, grading criteria and requirements can be taught, but visualizing is something that is just very personal. But if you are able to do it, and if you are able to develop that kind of thinking, then you're going to be very successful at grading, regardless if you're good with computers, with software, and so on, because those things can be learned. But if you have imagination, then you're going to be really good at this, I believe. So if we take this simple 2D sketch here, which is kind of based off of this one, and try to translate it into 3 dimensions, we basically have to think of it in kind of a profile view or a cut section. So we would have the existing ground, which would from the side look, maybe something like this. And then we have the water body. So we may kind of imagine, okay, this is going to be somewhere here. We're going to have an exact kind of idea of the elevation of that water body. So let's say that this contour right here is at an elevation 100. And so we know that that's where our water body has to be, just sitting tightly at full capacity at elevation 100. So from there we can infer where the elevation of the dam crest is going to be. So normally we would want that to be at least 1 meter higher so that we can have some freeboard. So let's say that right here is 1 meter higher than the water level. And then we just have to decide, okay, how wide is this crest going to be? Is there vehicles that are going to be passing over it? If so, then maybe we want it to be at least 5 meters wide or 4 meters wide. So these are criteria that you will be provided with. You don't necessarily have to figure those out yourself because they're written down somewhere in the documents of the agencies that govern these kinds of work in the particular jurisdiction that you're working in. So these are not things that you have to figure out. They're just provided. So you just have to make your models according to them. So again, like I said before, this is the easy part of grading because these things are just spelled out for you. But so let's say that we decided on the width of our crest, and then it becomes again very easy. We just have to grade down to the surface normally. And again, the slope or the ratio to which this batter has been graded is again another criteria that somebody has provided you with. So it's not something that you necessarily have to figure out most of the time. Likewise, on the other side, we grade down to the surface. If you had to have a keyway underneath the dam, this is something that will be revealed during geotechnical investigations. And again, there is criteria somewhere provided for the dimensions of that. So it may look something like this, and it's also provided in documentation where exactly it should be placed relative to, let's say, the crest or the embankment. So you don't have to figure any of these things out. You basically just follow the documentation and you use the software to grade according to those dimensions. So if this keyway has to be at a certain depth below the existing ground, then you just place it there, and then you grade upslope. So you grade towards the existing surface. So instead of grading down, you grade up, again at a certain grade that will be provided for you in the documentation. Likewise, it is for the excavation pit. So the excavation pit will normally join directly with the embankment. Sometimes you may have to have a bench. This is again something that will depend on your particular project, and it will be normally reviewed by geotechnical investigation, what you should actually do, and also by documentation. Some jurisdictions simply require you to have benches between the excavation pit and the embankment. Most don't. So you can directly join the embankment with the excavation pit, and then you just grade down again to a certain grade and depth, and again then you grade up to the existing surface. And so all of this becomes your excavation pit, the material of which will go to build the embankment. And then you may have to create a spillway, which again is just the same. In this case, you can see we have this kind of a more circular looking spillway. Again, you just place it where the inlet is at the elevation of the full capacity water level. That inlet will have a certain width. In this case, it was 7 meters. This is all again provided with for you through the grading criteria that you should follow. And also you have an outlet, which also has a certain width from the edge of the embankment. And you may also have a slope on the bottom of that spillway. In many cases you don't have that, but you may have it in some cases. And once you have all of that, then the shape of the spillway is already defined from all of these criteria. And then all you have to do, really, once you mark the bottom, is to grade upslope to the surface, so that you're going to create this small grade here, in which case we have a 1 to 2, and the spillway is basically complete at that point. But again, in no part of this process did you have to actually figure something out yourself. Most of this is provided for you. What you have to do is to be able to visualize that in how it's going to look in 3 dimensions, and to simply execute it according to the grading criteria through the grading software. So you do need to know a little bit of the grading software to be able to do this, but most of all, you need to be able to visualize this stuff before you can actually do it and do it well. And it really is no different with roads, because roads are just basically an alignment. So you first of all mark the center line of where the road should be, and then you simply project an assembly, or what's called an assembly, along that alignment. And an assembly is basically if you take a section of the road and you make a cross section of that, then that road an assembly of that road is going to look something like this. Let's say we have an insloped road. So we are going to first of all mark here the fill slope. This is the fill slope. And then we have the top of the road, or the travel way. So this is going to be something like this. It's a little bit too extreme for an inslope road, but just for visualization purposes. So we're going to have, let's say, 3% of inslope here. And then we will have also a fill slope on the other side. You may have some variations, of course. So you may have a ditch here, or if the road has a different profile, there may be ditches on both sides. You may also have a shoulder. So before the actual road, so there may be like a shoulder here, maybe let's say 0.5 meter of a shoulder before you actually get to the travel way of the road. So these are all small details, and again, most of this information is provided to you in documentation. You don't have to actually figure most of this stuff out. But what you should be able to do is to visualize how you can build all of this. So once you have created your assembly, then this piece is simply projected across the alignment of the road. And the software does the rest of the work for you. It manages to calculate how all of this connects to the existing ground surface, and where you may have to cut, where you may have to fill. All of this stuff is something the software figures out. What you have to do, again, is to be able to visualize the building components and to, again, know a little bit of the software to be able to execute this process. A road will also have a profile, and on this profile you can dictate how the road travels relative to the existing ground. So the existing ground is this thin gray line here, and the alignment of the road is the red line. So through the alignment on this profile, we can manipulate the vertical aspect of the road and where it may have to cut and where it may have to fill through the or relative to the existing ground. Through the alignment, we can also create things like, or features like rolling dips, for instance, to facilitate drainage. And again, these are simply structures that you can grade very easily through an alignment just by following the criteria that you've been provided with. But again, in none of this did you have to figure anything out except for just visualizing where these things should go and the way in which you can build them. The actual technicalities like the grading criteria, these are provided for you, so you don't have to figure those out necessarily most of the time. This will become more clear as we go through the course. I hope I was able to explain this to some degree, but to get back to my point, to be able to be successful at grading, you just, for the most part, need to be able to visualize things that you receive as a two-dimensional representation into 3 dimensions. And then you may need to be able to know a little bit of the software. But if you have strong imagination, then grading really is not that difficult, and it is a very interesting field, and it can also be a good business for you because not many people actually offer that service from what I've seen, especially in our sphere of work. And it would be good if more people offered it because there is, in fact, a lot of work to be done in that area. In the next session, I'm going to lead you through the actual process that we're going to follow in a lot more detail for each of the type of structures that we're going to create. So for dams, we're going to have one process. For roads, there's going to be a somewhat different process. They're all very similar. They all follow the principles that we're talking about here, but they have their little nuances that you should know. And all of these videos in this overview module that deals with the workflows are meant to be referenced so that if you ever get lost during the course, then you can come back to these videos and kind of get an idea of where you are in the process and get a more general overview of how things work. And I will also mention throughout the course when it may be a good idea to actually come back to these overview sessions and to actually see where you are in the process. And I'm going to specifically also myself come back to these charts, for example, the water storage pipeline, and I'm going to mention where exactly we are in the process so that it can perhaps help with providing you with a sense of orientation. For now, this is it for this video. I hope it has been useful in giving you an idea of how grading works and how you can think about it. And now we're going to proceed to covering the workflows that we're going to be following for the different type of structures that we will be creating. Thank you for watching, and we'll see you in the next session.